Hi everyone, and welcome back to my channel, Dr. Coco's Medmonics. Today I'm going to be going over statistical bias. This was a YouTube request, and honestly these biases are not that bad if you can kind of figure out what the word means that the bias is named after. And sometimes I think of these as like different examples, and it kind of helps me if it has a story behind it. So let's just go ahead and start. First, we have selection bias. And what do you think selection bias means? Well, first, bias is because you weren't random. So for every test, in order for it to be significant, you'd want like a population that looks as close to the normal population. So some are sick, some are healthy. But if you're not random and you don't have a random sampling, you're going to have some sort of bias. And so that's what this whole video is about, is like the different types of biases and errors that you would get. And so for a selection bias, that means that you didn't select randomly, okay? And there's two different types of selection bias, the Berkson bias and attrition bias. Berkson bias I've never had a question on, but I try and think of it as Brokeston's bias instead of Berkson. So the patients were broke for Brokeston, and that's just because if you can remember they're broke, then they're probably not as healthy as other people, right? So this is going to be a population of individuals who are less healthy, and it doesn't look like a normal distribution of the population. So in America, we're looking at a lot of people who have, say, cardiovascular disease, and that's a good chunk of our normal population would have that. But say we had a group, and instead of having a normal distribution of healthy and non-healthy, most of the people have cancer. Well, is that a good distribution for sampling? Well, no, it's not really random anymore, right? We have selected for a group that's less healthy, and those less healthy people are broke, for Brokeston bias or Berkeston's bias. And next one for selection bias is attrition bias. And for this one, it's a loss to follow up. But the way I think of it, when I was looking at medical schools, I was looking a lot at attrition rates and whether or not, if you started at that medical school, would you finish there? And I like American schools and international schools, a lot of them have a poor attrition rate, meaning that you would start medical school, you wouldn't finish and you wouldn't graduate. And a lot of people assume that that's just Caribbean schools, but it's not. There's a lot of U.S. schools that fail students. And so it was really important to me when I was looking at medical schools that I had a school that had a high attrition rate, meaning that the people who started, most of them finished. Because I didn't want to go to a school that failed you because you wore like the wrong shoes to class or something. That just wasn't me. That wasn't the environment I wanted to be in. And so if you can think of attrition rates in schools, whether it's medical school or wherever you're at, then you can think of attrition bias, which would be patients that are lost to follow-up. So they started with you, but they did not finish. Next, we have some performing biases. So first one is recall bias. I just think recall, can you recall something on a test or not? Well, that's you remembering it. So if you have a recall bias, it's probably because you had a patient, they had to self-report something or do maybe a survey, but it was like a year later and they can't remember shit that happened a year later. They can't recall it. And a way that you would get over a recall bias would just be to like decrease the time, right? So one of the things I think of is when you do an investigation for like a food outbreak, that person who had salmonella may not have known that they had salmonella, and then they have to think of all the foods that they ate like 2 weeks ago. And to be honest, I can't remember what I ate yesterday, and these people have to come up with all the things that they ate, every restaurant they went to try and figure out where exactly they got salmonella from. And them not remembering it would be a recall bias. Next is a measurement bias. So this is where you measured something wrong, right? So you gathered your information as the researcher in a way that may be distorted or something. I just think you measured it wrong and it did not work. And one of the parts of measurement bias is called the Hawthorne effect, and this is where participants change their behavior based on the fact that they're being observed. And there's a lot of different situations where this has happened, where, if a doctor goes to see a patient, normally they're kind of an ass, but then when they know that they're being observed, say in some type of situation where they're being recorded, they're going to act differently, right? Like for the steps, back when you used to see patients for step 2. But I like to think of Hawthorne, the way I think of it, as they're hawks, and in medical school we call them gunners, but in undergrad we called them hawks, just because they were the students that would stab you in the back the second that they got a chance, right? But they were the top of the class because they would do stuff like that. They were the gunners. They would stab you in the back just so that they could get an A and you could get a B. And that's just because, they wanted that higher grade, but when they're being observed by a professor, they would act totally different. So that's like the Hawthorne bias, or gunners, and is what I think, like hawks, because they act differently in front of authority figures, or they act differently when they know they're being observed. Procedure bias, this is where you'll have different groups and they're not treated the same. So you're doing a procedure on somebody and you're doing it on all of these different groups, but you're not doing the same procedure on every person. Or if you're doing the same procedure, you're not treating them all the same way. And part of me thinks of procedure bias as almost like, I don't want to say racism, but there are doctors out there that are racist and they will treat one patient one way and another patient another way. And that would be a procedure bias, right? They're not, following their procedures correctly because they are biasing on the way that person looks. And then observer-expectancy bias. So this is where when you, the researcher, are doing something and you're like, okay, I know this drug that I made is awesome and it's going to work so well, and you're expecting it to go well. And that kind of changes the way you look at the data and ends up changing the outcome of the research. So that makes sense with the words, right? Observer expectancy, you're expecting something to happen, so then you see it happen. I also kind of think of this as many people get obsessed with numbers, and for a while there I kept telling myself I was seeing the number 8 everywhere and the number 8 must mean something, but actually it's just an expectancy bias, or an observer expectancy bias. I'm observing and I'm expecting to see the number 8 everywhere. And is it actually everywhere? Probably not, but that's the way your brain works. So you expect something to happen and then that changes your outcomes. And the interpretation bias, these are the ones that I get the most questions on UWorld and BMEs. And in my head, they kind of are the harder ones. So that's probably why you'll see them more. First one, super important, confounding bias. So this is where you'll have an exposure that's distorted to the outcome. And that, honestly, that definition sucks, but yeah, first aid, there you go. But the way I think of it is drinking alcohol does not cause lung cancer, correct? We know that drinking alcohol can cause liver cirrhosis and, a lot of problems, but it doesn't cause lung cancer. But we know that smoking does. And so when we say that somebody who drinks alcohol is more likely going to have lung cancer, well, is it the alcohol that's causing it? Well, we know, we have to bring from our medical knowledge that we know that that's not the case. But people who drink alcohol are more likely to smoke. And smoking, we know, does cause lung cancer. And so drinking alcohol is the confounding bias. We think that because they're drinking alcohol and they have lung cancer, that it's the alcohol causing it, but it's actually not. That's a confounding bias. That's this outlier. We don't, we're not considering that as the problem, but you might consider it a problem if you can't take from your medical knowledge that, hey, alcohol does not cause lung cancer. Because at some point in our lives, well, not my life, but at some point in history, we did not think that lung cancer was from smoking. And so confounding bias can be really hard to observe, but on a question stem it should be very obvious. Like, we know alcohol does not cause lung cancer, but we know that alcoholics are more likely to smoke, or smokers are more likely to drink alcohol when they smoke. So then that would be the cause of that cancer. Next is lead time bias. In both lead time and length time, they both start with L's, and I try and put that into a category in my head that these are both talking about using a screening test. So lead time is early detection, looks like increased survival rates, and the disease has not changed. So we're thinking, say, breast cancer, and we know that if you detect breast cancer early, you might be able to treat it. But does the disease actually change itself? No. But we think that early detection makes it look like we're increasing our survival rates, whereas that woman may have still died at the age of 50, whether or not we got early detection. But because we did early detection at, say, 35, well, we're saying, oh, well, because we found it at 35 and she lived at 50, she had a 15-year survival rate. Whereas if we'd found it at 45, she would have had a 5-year survival rate. So detecting it early leads you to think that you're increasing your survival rate when you actually aren't, because the nature of the disease has not changed. And so I use it as detecting early leads for lead time bias makes you think you're increasing your survival. And you have to know the difference between that and length time bias. And length time is screening test detects a disease with a long latency period. Well, what does that mean? So slower cancers are more likely to be detected by screening versus a fast-growing cancer, because those are going to be more likely to have clinical symptoms, right? So I think length of disease progress skews your data. And you can think of like maybe like a adenocarcinoma of your gut or something like that, where if it's a slow-growing cancer and there's no symptoms that the patient's seeing, they're more likely to get a screening test. Versus if it's a fast-growing cancer and they have symptoms, are they going to get a screening test? No, they're probably going to get a diagnostic test. And so that's what's going to cause this length time bias, where the length of the disease progress will skew your data. Hopefully this helped you guys, just going through some examples and talking through the different names of the different errors. And if it did, please like and subscribe to my channel.